Very good evening to all of you, and I'm happy to see that there is enough participation from students. I would run probably 40 minutes around. So, as Sai must have brought out that today there are 3 speakers for this course launch event, and Dr. Arun will be taking forward further, and further Mr. Ravi will be taking forward. So my topic is a little broader in the sense to give you a complete picture of little orientation on the technology and how this course can help you in securing job within Unistring or similar industry, which is outside either in VLSI domain, ASIC domain, or FPGA domain, or in high-end embedded system domain. So the agenda goes like this. So I'll be talking little on, most of you are aware of front-end and back-end, but I'll apply to the context related to FPGA and give a little deeper insight of what is front-end, back-end. Then there are a couple of slides which describe about the different job roles. This is very important because we at Unistring mainly believe in role-based training and ensuring quickly fresh engineering graduates with undergraduate or postgraduate program. Within few months of training, they should become productive. So that those details I'll be discovering here. So coming to semiconductor and FPGA, there's a lot of data available on the market analysis. This is only for reference we gave. Then more details about the RTL engineer. So why this course? How should it help you? That's the main part in next this part. Then we will be talking about the skills. So this is the main content which you will get a bigger picture. What skills you will be getting enhancing through this course, both in terms of subject concepts, but also in terms of the tool usage for doing practical designs. Then you have a broad outline of the course. The detailed course content, Mr. Ravi will be covering. Then we will be talking about 2 popular FPGAs on which Unistring works. One is Zynq family, and other one is Versal, which is advanced FPGA with AI fabrics and all. Then we will be talking a bit about FPGA-based embedded, because some of the companies which use FPGA, they call that as an embedded. Some of the companies, they use word VLSI, but both are the same. So we will be talking about that. Okay, so make this discussion, fully interactive, and whenever you want to interrupt, you want to ask any question, so please unmute yourselves and ask the question. Feel free to discuss anything. The purpose of this total event is to give you a bigger picture. Most of you in your mindset, what is VLSI, what is front end, what is back end, specifically related to FPGA-based high-end defense and aerospace industry. The intention of this initial session is to give you a bigger picture. So you make a clear choice whether this course is relevant to you, useful to you, and decide to continue this course. And eventually, in between, we are going to conduct the written tests and assignments and all. So once you are above a particular threshold, then you will be given job offer by Unistring. We have a decent number of openings. I would say, at least in my view, I think our Ravi and Sai are the right people to quote the numbers. But what I broadly remember, at least 20 plus openings are there, and we have a target to pull out from this course only. Okay, coming to the front end and back end, these kind of diagrams you must have seen in several textbooks. So there's no point in dwelling much on this. So the RTL is a very broad word. So some of you know what is RTL, right? Can anybody speak out what RTL stands for?
Register transfer logic.
Yeah. So register transfer level, I think.
Level.
Yeah, it's level. Fine. Okay. So RTL basically, like you are trying to say, how the data is moving across the registers. These registers are nothing but the registers and counters that you studied in your VLSI digital codes or a VLSI code something. So invariably, any digital design, when it is synthesized, if the design is describing the VHDL or Verilog, if it is describing your digital design in the form of how a data is moving across registers, then only it is synthesizable. That's the reason RTL is used as a synonym for VLSI front-end design. So people call VLSI front-end design and RTL design in industry. Both are used in a similar context. So any digital code that you describe through VHDL Verilog, if it is synthesizable, then it is definitely an RTL code. There are ways to write a VHDL Verilog code also in a behavior style, putting for loop inside, if condition inside, a while loop inside, like that. But most of the times that is only simulatable. It is not synthesizable. Even if it is synthesized, its performance is not guaranteed to work. So RTL is a word. So it's very simple. Maybe when we start discussing the VHDL syntax, Verilog syntax, we will go deeper into this aspect. RTL is nothing but a specific digital design style which is mainly suitable by coding kind of technique like VHDL Verilog. You describe your digital design requirement as a data moving across registers. First register, second register, third register. Between first and second, you have a mux. Second and third, you have some comparator. So that's what is the concept of RTL. So now you pretty much understood. You have high-level specification. For example, company like us, the high-level specification could be a radar algorithm. In radar, you have a pulse compression, matched filter. Or in any simple wireless communication or a DSP biomedical application, the specification could be you have a 16-bit ADC or a 14-bit ADC, you have to implement an FIR filter. That is specification. Or in a driver development logic, the specification could be you have a rocket IO on which you are getting some data which you have to convert from serial to parallel. That could be specification of a VLSI design. So high level thing, you have a specification, you translate the specification to RTL diagram, then use the HDL, okay, hardware description languages like VHDL Verilog, they describe the hardware. So you code using the RTL standard or RTL style, then you do functional verification. So this you'll use a simulation tool, could be model sim tool, could be Xilinx inbuilt simulation tool, could be Synopsys simulator. This is a functional verification. So in functional verification, we do not think whether this piece of code is becoming a mux, whether this piece of code is becoming a register, what is the clock speed, that is not addressed here. Then we do synthesis. So in our course, as I already mentioned, our company does VLSI, but we do only FPGA VLSI. We don't do ASIC. So we do not use the ASIC synthesis tool. We use an FPGA synthesis tool. So where you convert your VHDL code to FPGA gate level, mux level, flip-flop level. Then again, there is one more simulation. This diagram do not show that. You can do one simulation called as a timing and placement, post place and route simulation, people call it as. So people usually don't do it for big designs. They occasionally do when they have to do a lot of troubleshooting and all in FPGA industry. In ASIC, maybe it's a standard practice because in ASIC, the effort of or the cost of making one chip and manufacturing it, then realizing there's a mistake is huge. But in FPGA, it is not. It is only available at your desk. So instead of thinking that I will do post place and route simulation here, I will just put it on FPGA, and only where there are clock issues are there, I might simulate only in those areas, the post place and route simulation. Okay, then you do the physical design. So some of these steps are not applicable to the what is called FPGA-based design. They are applicable to ASIC. So if you go deeper into the FPGA, so you do design entry, there are something called constraints. So you apply pin constraints because in your design, the FPGA as a chip, it has got multiple banks. These all will be taught in the course. So different banks, each bank has got some constraints. Like some banks, they work with some power supply, some voltages. Saistri, please help me in alerting when I am left with only 15 minutes. Okay, my talk is intended for 45 minutes, roughly.
Sure, sir.
Yeah, so then I have only that what is called pin constraints are there. Area constraints rarely people apply, but yes, I have seen some advanced designs where 70-80% usage is envisaged, then people do also apply area constraints. Then some of the simple area constraints most of the FPGA designers use. For example, the synthesis tool tries to optimize for area. It removes some of the design, thinking it is unuseful. So synthesis tool is all the time not intelligent enough to discover that optimizing. So people realize that the way how you code, sometimes the synthesis tool will actually remove the logic. So we will add one constraint to keep an attribute kind of thing. We will tell to the synthesis tool that don't remove this and all. Such kind of constraints are done. Then you do synthesis. Then it also further synthesis is like translating the code to a synthesizable blocks. Then translate is a place where synthesizable blocks which are generic across all FPGA devices. So synthesis is common. If you take Xilinx synthesis tool, the synthesis is common from for any device family, Zynq or Versal or Vertex, anything is same. But when you're doing translate, I keep what is underlying FPGA in mind. If it's a Zynq FPGA, I have some type of MUX, some type of DSP48 slice and all. If it is Versal, I have a different. If it is Vertex, I have a different. So that is taken care in the translate. Then you do a lot of simulations and all. Then you modify the design. Then you do it. Then you have map. Then place and route bit generation. So mostly people in FPGA industry, because there is no much cost in testing really on the hardware, they want to directly jump all these stages and do the bit file generation. In Zynq FPGA, there is something called ELF generation. Bit file is for your FPGA fabric. ELF is for your ARM9, where you write the C code. More details are in subsequent slide. You program and check. Even though there are things written like static timing analysis, this analysis, people do timing analysis, but they don't do simulation with the timing model, because that's a very time consuming thing. If you start a design, we have even seen where functional design itself for our radar project, if I apply night simulation today evening, then tomorrow morning, hardly we are able to simulate up to one chirp of a radar, like, even one dwell, what you call, some 16 pulses or 32 pulses and all. So, okay, now we are moving on to the next topic. So look at this. This slide is also meant for giving a bigger picture and to tell for whom this course is more useful, for whom this is not much relevant. So if you look at all these slides, wherever given in a red font color, they are not seriously covered in our course. The concept still remains same. Like we talk about here also memory tests, here also some verification, functional verification, random verification things with our test cases and all. But I mean, to be more precise, these areas which are popularly dealt by several training institutes in Hyderabad, Bangalore, Delhi, Mumbai, Pune, all these places, there are so many institutes who talk about the ASIC verification with system verilog and all ASIC industry. This is not for that. This is not that kind of course. This course is intended for building architects. Okay, people who develop applications in VLSI, not for the people who do verification in the VLSI. So we are not focusing on it. So in our course, we focus on front-end design. We talk about RTL, this one and all. We talk about more the FPGA related, how do you test bench, and we will not go in deep, but we'll talk about the 100% code coverage, functional coverage with coverage analysis and test bench. We definitely talk about the backend design, but we don't do this backend. We do FPGA backend. I think my team member who made this slide, he missed one slide. If it is FPGA backend, then it would have been in a white color. That we'll be talking backend design specific to FPGA. And in verification, yes, we'll be doing enough FPGA verification with chip scope, hardware emulated, a lot of things are there. We'll be covering that. So this slide is also meant for giving a bigger picture on if you want to secure a job in VLSI, what are all different job roles you can envisage. Look at this layer of the slide. RTL engineer is one type of job role, functional verification engineer, FPGA verification engineer. So you can expect that in our company, when you are given job, you will be given in these three areas, 1, 2, and 3. By and large, the FPGA synthesis, which I said is missing, is being covered here, FPGA verification engineer only. So people who are very good at understanding signal processing, digital designs, FIR filters, people whose DSP concepts are also fairly good in our company, because mostly what we build is radar and wireless products. So they will be here. People who are good at those concepts at the same time, who are very good at validating the system. Even more intelligent people than the coders will be working here. So we will call them as RTL V&V engineers. People who are not that good at coding, but they are good at FPGA hardware testing, protocols, different interfacing protocols, ADC, UART, Ethernet, those things. So these three are the job roles in which we will offer job positions at the end of this course. And these three roles put together, we have 20 plus openings in company. And let me tell you guys, this is what these two are the most phenomenally high value, what is that called, roles in any organization in India. provided if they're doing designs. Okay, if they're only verification company, they're having a foreign company collaboration and you are only working as a verification engineer, invariably these are the things. And if you are aiming for such job, this course is not a good course for you. You should join some verification course offered by several institutes, which are there in Bangalore and Hyderabad. If you are aiming to become a designer, a VLSI designer to build an application, and that too if it is somewhere connected with different signal processing, wireless industry, 5G, or any protocol development, then this course is certainly helpful. Either it is FPGA job or it is an ASIC job. So more details about FPGA. So they call FPGA design engineer, verification engineer, firmware engineer, FPGA debug engineer, but these are okay, fine. Whether you call FPGA or what is it called, test engineer, they are by and large the same. Okay, now I am getting into the next part of my presentation. Any questions you have so far? Okay, at the end, anyhow, I'll open up questions for everyone. Now this slide is showing, like, I think this is a little redundant, but for the sake of completion, we have kept. Most of you know that the job opportunities in VLSI are always lucrative. They are very attractive packages. Intentionally, I told not to keep package here and all. But you know that VLSI jobs are considered to be the premium segment jobs, because there is a combination of software, what is that called, chip design, and application development. 3 levels of skills will be needed. So this slide shows about how globally they are there. So you have plenty of information on open literature. This is another slide where Mr. Ravi wanted you to understand that in the specifically FPGA-based design, how deeper we people are working on. So a lot of companies are in India. Some of the companies, they may not call themselves as a VLSI company, they call as an embedded system company, but still they'll use FPGAs. And FPGA is a good starting point to become a VLSI designer, because in a VLSI design, if you want one chip tape out to happen, it may take 6 months to 1 year timeline minimum. But in FPGA, you can see whatever the code that you write, by end of the day, it will work on your actual hardware, matching with almost the ASIC speeds. And by and large, the defense aerospace industry has to work on FPGA only, because in defense industry, it is very difficult to freeze standard and make one chip and produce in millions. In defense industry, requirements keep on evolving, okay, with as the market is changing. So like our company, several defense companies only rely on FPGA-based VLSI design. Okay, why should you take this course? What is the benefit? So RTL engineering course is designed to prepare the fast-growing, high-level demand VLSI, FPGA, and defense embedded. You know that the government of India, central government has phenomenal, subsidies given for the defense industry. Most of the defense equipment they want to, make in India. Atmanirbhar Bharat. These are all schemes are trying to encourage the Indian defense industry. So I would say there are hundreds of startups which have come in the defense aerospace industry, who would require the company like us is anyhow established more than a decade and all. But these all people need, experts, defense, aerospace, biomedical, 5G. Even in 5G, India has very strong policies. They want to encourage the Indian industry and all. So you know very well across the internet, the fight with, what is that called, Elon Musk's Starlink, and encouraging the Indian-based systems and all. So all these are very good sign, and the people who got capability of this VLSI, FPGA, and defense embedded system capability, you have phenomenal job opportunities. What skills you will be getting developed? You will be extremely good at RTL design by end of the course. You will be talking about the FPGA programming. You will be talking about the test bench. And you will have basically, because our company is working on RF and radar, so invariably the assignments, the projects that we give would have some commonality with signal processing about the RF radar and all. Then you will be learning, most importantly, the industry used documentation style, whether it could be telecom industry, defense aerospace industry, biomedical, any sector. There is some commonality, but mostly we'll be training on defense standard. But you can understand, like, defense standard is a more stringent standard. If you understood the defense standard, any other standard, you will be able to easily understand this. So these all skills will help you to secure a good job, whether it is our company or any similar industry. Yes, as I already mentioned, these are very lucrative job opportunities. So you have signal processing, wireless, this one and all, 5G, telecom, AI, machine learning in defense and aerospace, in autonomous vehicles. Just a second. Yeah. So I think, yes, this is what there's a continuation of the previous one. So point number 3, you will be learning about the signal processing, wireless FPGA, ASIC, total one. So we'll be taking some case studies of Versal where you are using AI. So, for running AI algorithms, you need GPU class of framework. So that is there. We will be covering in our course, and you will be getting a lot of hands-on. We will guide you how to get a license on your tool, and your all assignments are going to be real-time assignments. None, even though you are sitting across computer, sitting anywhere globally, you will be working on real-time assignments only. Then maybe depending on the how framework goes, our corporate trainers may arrange one-day visit to our company. People who can afford to traveling to Hyderabad, if you're already in Hyderabad, good. So we will show you in company what all we do, maybe at the end of the course. But mostly our course is online. Everything you'll be sitting online and learning. You have to do a lot of assignments. It's not just easy. It's not a classroom kind of thing. It's mostly hands-on kind of course it is. Most importantly, which you don't find in any of the VLSI course except the Sandipini and the CG Corel offered courses. Except them, remaining all courses, they don't talk about the signal processing IP course and all, which we cover in our course. These are become essential to build any such application. Then you are going to get a very, very strong base to build a stable career. And unlike typical software industry, these type of job roles are very much resistant to industry fluctuations, such as software boom is not there and all. That is not the case in VLSI industry. It is evergreen. But of course, it depends on, like, if the service-based industry is likely to be with the service-based industry has a problem of getting affected with the global recession and all, but product-based industry is not so. Ask Aisha to receive. Yeah, he can be sitting in the software conference room, right? Return on investment. So given on increasing salaries and strong job market and demand, so this is one important thing later. So key skills required. So now I'm getting into the skills part. So you can understand that so far what I covered is about the main reasons why you should take this course. What is takeaway from this course? Okay, fine. You appreciate, it is appreciated that there are good job opportunities and these are the reasons. But what is it exactly I'm going to learn out of this course? Look at here. You already know you did digital design course, so we don't expect us to teach the AND gate, NAND gate and all. That's all prerequisites. We directly start with the digital electronics, and I'm sorry for typo error here, digital electronics and logic design. So we'll be teaching on the very important things like, as I mentioned, that register transfer level. Okay, we'll be talking about that. And while talking, we will also give you the enough insight of the digital design, which is needed for the VLSI. Then we jump on going into the coding. But here also, we expect you to do some little self-learning and all. We cover the VHDL Verilog coding at a top level to cover the concepts, but we give you enough assignments and examples, case studies. You need to become master. Okay, then FPGA development tools. So you will be looking at mainly the Xilinx. As I mentioned, in our company, we only do Xilinx-based FPGA design, mainly the system on chip design with Zynq FPGA, hardware software co-design. So we'll be using these tools. Then that's what you'll be learning, the skills that you're getting. Then DSP algorithm. Now this is something which is rarely available. Hardly I say any open domain available courses, even though they charge 50,000 or 1 lakh, whatever they charge, they cannot teach this because this is only known to the companies like us who build the products. Okay, or any special summer courses offered by IITs or reputed universities, they might cover this. Not any typical training institute offered courses. And let me tell you guys, this course is offered free because our interest is to build skills in the engineering pass out students, and whomever is willing to join us, we want to, give job offer at the end of the course and take it. Whomever do not want a job offer, but still okay, you are to join some other Indian company, some other product development company, and hence you will be giving productivity, and hence GDP of the country will grow. So we are not expecting any financial support from you, and no fees for this course. In spite of this is having an in-depth content. Only the people who are keen enough to build, who are also ready to give their time in terms of practice and commitment, can only continue with the course till end. Otherwise, you will drop in the middle, wasting your time and our time. So be clear. Hardware design and debugging. So we tell you about a lot of on-chip debugging tools. Okay, we talk about the JTAG boundary scan, which is common to FPGA and ASIC, but by and large, we'll be going deeper into the chip scope. We will also talk about some debugging tools like a Wireshark, Hercules kind of tools, which are used in embedded industry. Because chip scope is on-chip debugging, Wireshark and Hercules are interfacing debugging tools. So we will be going deeper into the advanced FPGA concepts. So we will be talking about the clock domain crossing, multi-clock domain chip, and how clock tree is synthesized, how the clock buffers are inserted automatically for big FPGAs, all that we'll be talking about. In this context, we'll also talk about the IP core, some of the, like you have DCM, digital clock manager, which is Xilinx IP core. So specific to the IP cores, which are the ASIC blocks inside the FPGAs also we will talk. But everything we talk will be specific to Xilinx FPGAs, mainly Zynq. FPGA-based processors, we talk inside the Zynq, you have ARM9. So we will also do a small example coding on ARM9. But the focus of this course is not complete ARM9. Even though we give you a basic understanding about C programming in ARM9, that's only you to get a feel of interface between the PL and PS. What is PL, PS? I'll be covering in my next slide. PL is a part where you write your VHDL code, and PS is the part where you write your C code, which works in ARM9 processor, which is inside the Zynq FPGA. So the major emphasis is on PL, which is a VHDL Verilog based design. Okay, we will be talking about the performance optimization. That is extremely important. Companies like us, we process 1 gigahertz bandwidth at a time in the FPGA. How do we do that? Okay, we'll be talking some case studies. So we'll be talking in depth about the test bench. So as I mentioned that 100% code coverage, 100% functional coverage. In this writing test bench, we do a lot of scripting, which has commonality with the ASIC verification also, like, but mostly applicable to ASIC signal processing chips verification, not the popular ASIC AXI-based verification. We will not be talking much. We'll be doing still AXI-based design, but mostly connected with the FPGA. But this verification is more about writing test benches, integrating with the MATLAB, or integrating with C program, or some scripts related to Perl or something like that, where you can automate the FPGA-based verification. So as I mentioned, we will be talking about IEEE 12207, which is industry standard. There is little enhancements to that, is called MIL STD 498. So we'll be talking about these standards. Our team did not mention here, but there is also an overview of DO 178B, which is airborne airworthiness standard, which is used in the aerospace industry, also will be covered in this module. Okay, so I gave you a glimpse on what are the skills that you are going to get. So I think things are clear. This is a set of four headings are given here. Then another 6 headings are given here. Probably this will run through some 15 to 20 sessions. I think those details, anyhow, Ravi is going to cover in depth. So these are the course modules. Yeah, so I think this will be a little repetition of what I have to say. But let me see some certain things which are not there. Like, for example, we'll be also talking about some instruments which are used in wireless and 5G and defense industry. We'll be using signal generators, spectrum analyzers, all this. This is one important thing. We'll be also talking about this integration with MATLAB, other V&V verification and validation tools. Yeah, so probably this is all self-explanatory. I'm not going in detail. Okay, I've come to the next part of my presentation where I'm talking about little architecture of this FPGA. But again, focus is like what you're going to learn in this course. So this is about the Zynq FPGA. How many of you know Zynq? Just type in your message, chat message. Yeah. So, Saishri, fair enough. I have, okay. So, see, this is a little deeper topic. With a limited time, maybe in 5 minutes, I'll give a bigger picture. Maybe I stop screen sharing for a while. So, guys, there's a lot of jargon that is there in the industry. People talk SOC, system on chip, RTL, VLSI, front end, back end. This is very important. First, you make yourself familiar with this. Otherwise, you don't understand, where you fit in. I mean, like what exactly you're capable of. So one of the word that popularly people use is called SOC. So if somebody says I'm working in SOC, you understand what probably they must be working on. So if it is a company maybe I take big company names, but there are several small companies also in that, let's say Broadcom, okay. This kind of companies, Broadcom is a company known for making these wireless chips and all, right? So they do, what they mean by an SOC is like, so they have got some ARM core. So what happened, around some 25 years before, when the processor architectures wise, there is there are different architectures came, there is a RISC architecture, there is CISC architecture, then Intel x86 is one architecture. The CISC and RISC are the broad what you call theoretical terms which are used rather than general architecture. So Intel architecture is there, then PowerPC, IBM has come with a PowerPC and also around 25 years before, roughly, or probably I should say 30 years, 25 to 30 years before, some innovators, they realized that there is a necessity of building a little hybrid kind of architecture, and that architecture should meet most of the embedded requirements. That's where the ARM company has started. ARM, ARM that you talked about, So that ARM architecture, when it has become popular in the mobile multimedia industry and all, then ARM company has changed their mode of business. They said that, okay, look, I am ready to give my ARM as a core. Okay. So when somebody says that they're ready to give as a core, again, there are different type of cores are there. Soft core, hard core, or what you call as a silicon core. IP, people also call as today as a IP, soft IP, hard IP. Okay. What does it mean is, if let us say the ARM company gives about their architecture, their whatever the ARM architecture, ARM entire processor as a VHDL code, Verilog code, and gives it to any company like a Broadcom or anybody, okay, you synthesize. Now the Broadcom might have their own 18, some nanometer foundry or maybe 9 or whatever the processor technology nodes are there. They can synthesize the code. They are only going to make. The another type of ARM cores that they are sold is hard IP or silicon IP. So what ARM does is, okay, which technology node you are, let's say Broadcom is at some 18 nanometer technology node or some technology node. For that technology node, already the design which is at, the CMOS, BiCMOS, these all designs, right? There is a MOS layer, there is a metal 1 layer, there is a metal 2 layer like that, right? So that type of design files are given to company, and these people take that and around that they build their own additional logic, they send it to the fab. So today when people are talking about building an SOC, what broadly it means is, it is some parallel running logic. Parallel running logic means the VHDL code, Verilog code, which is parallel running some application. Could be in a wireless communication. You know that wireless, there is a wireless radio signal going on air. It means it has some modulation, demodulation, right? QPSK modulation, or you studied about those digital communication. If you have done ECE course, then you would know. If you have not done course, then at least understand that AM, FM, these are basic modulations are there. Something like in wireless industry, there are certain advanced modulation schemes are there. So those modulation scheme related blocks and other things, they write as their own VHDL Verilog code. And there is a processor IP. Could this be processor IP is a company own proprietary IP? Or could this be from a company like ARM or something like that, which is a bought out IP? Both these two, you do at some level, either at a RTL level. If it is a soft IP, at a RTL level, you combine and synthesize. If it is a silicon level, then at a physical layer level, you combine and synthesize and go to fabrication and get the ASIC manufactured. This is what you mean by SOC design. Same thing will happen in FPGA industry, slightly different manner. Okay. Look at the FPGA industry, how it has evolved. Okay, Xilinx has started in 1980s, I think 81 or something. The Xilinx was founded. Then after a few years and all, Altera was founded. So these companies, when they are writing, what is the philosophy of FPGA? That I'll be covering in my second or third session. The philosophy of FPGA is you have the FPGA standard building blocks like multiplexers, flip-flops, these kind of things are there. And you write your code, your VHDL code, Verilog code is synthesized. There are standard blocks are there, and there are switches in between that register, mux. I think some of you who did this gate and some government entrance exam, you must be familiar with one standard pattern of the digital question. They will give you one multiplexer. They will give input 1, 0 and all control lines. They give A, B, and they'll ask you what Boolean function is synthesized. You guys can recollect this pattern of the question in your digital question paper. So, or sometimes they give you a decoder, a 2 to 4 decoder or something like an encoder. They give you some 1, 0 input, some A, B Boolean functions, and they ask you what Boolean function is synthesized. This is what exactly happens in FPGA. In FPGA, you have basic building blocks, flip-flops, multiplexers, some lookup tables and all. There are switches. There are that's why they are called SRAM based FPGA, because using SRAM, these switches 1s and 0s are programmed. So these MOSFET based switches are used to connect and disconnect the circuits in FPGA. So when the FPGA industry has evolved, when in 1990s the power of SoC is visualized by the ASIC industry, the silicon industry, what FPGA industry was trying to do, they used to do the similar things, but because there is no silicon manufacturing there, whatever is soft IP core, that is using VHDL code, a processor that is implemented. I think I don't have to tell you what is a processor. Most of you studied 8086 processor architecture, 8051 architecture. A processor is which has got a CPU, RAM, instruction memory, data memory, ALU. That is called a processor. Because without processor, you cannot write any sequential coding. C, C++, assembly code. If you have to run them, you need a processor. So what was happening in 1990 era? That they used to take soft IP cores and do it. So there were two cores which were popular in 1990s. Still they are being used in embedded systems. It's not that they're not being used, they're used. Microblaze and Picoblaze. Probably, I don't know, Picoblaze people are not using it, but Microblaze will use it. That is soft IP core. Then what Xilinx has realized, any soft IP which is coming and sitting on FPGA fabrics is doing two things. Two problems are there. First, the soft IP itself is taking FPGA fabrics. For the application space, for the people who want to develop the parallel logic, the resources of FPGA are consumed for processor only. That's the first problem. Second problem is they saw that it is not running at fast. Why? If you build dedicated in silicon, any ALU or a floating point multiplier, fixed point multiplier, it runs fast. But if you don't build dedicated, you connect these switches, MOSFETs and all, which got their own delays. So obviously your processor core cannot run at high speed. So if you look at an example, just type in a Google or ChatGPT and ask it, what speed at which a Microblaze IP core can run and what speed at which ARM9 of Zynq can run. So you realize that ARM9 of Zynq can run at 667 megahertz, whereas a Microblaze can run at some 66 megahertz clock or 133 megahertz clock, something like that only, not high clock rate. It is because this ARM9 core, which is present in the Zynq, is a hard core. It means it is at a silicon level, it is present inside the chip. Okay. Hope this background is giving you a bigger picture. So system on chip is a design approach where you have a processor, where you have a parallel running logic, and I do timing closure and application closure for both put together. When it is done in ASIC, it is called SoC. When it is done in a FPGA, it is called CSoC, configurable system on chip. Okay. Now with this background, if you see this diagram, you guys can see that this complete thing is a Xilinx chip. If you see Xilinx chip, Zynq chip, this complete thing, you have this core here, which is an ARM processor core. This ARM processor is similar to any ARM chip that is available in your mobile phones or anything. It is a hard core. Then you have standard peripheral control blocks. You can recollect all these are peripheral control blocks. Then you have the PL logic. Just wait a second. Zynq processing system. Oh, this block diagram, what Ravi has put, only the PS system only has put. I'm sorry, he missed the bigger picture. The bigger picture of Zynq will have both the PL and PS together. Just give me a minute. I'll show you that. So you can see a bigger, a simplest high-level picture of Zynq. It has a PL. PL is nothing but where you write your VHDL code, Verilog code. You can implement anything you want. PS is the ARM system, so it will be like this. Okay. Okay, he has given here an elaborated picture of the PS logic here. Fine. So this is what about the Zynq. So when it comes to Versal, now this is the latest FPGA architecture, which is from Xilinx. So some of our products where we do a lot of signal processing computation or AI algorithm, we use it. So this fellow is like, it has three things in it. So in simpler words, you have to understand a Versal FPGA is equal to an a computer which is used in your laptop, and an ASIC chip which is used in your mobile phone, and a GPU engine which is present in a NVIDIA AI algorithm. It has all the three fellows. You see here on the left side where my mouse I am showing here. This is a place where you write your PL logic, where VHDL Verilog. This is a place where you have ARM cores. So you have dual ARM one, another dual ARM. There are two separate architectures are there. You can see A72 RS, R5F. These are slight variations are there. Real-time processor, application-specific processor. So it means effectively you have two dual core. It means you have a quad core processor here. Then you have a bus. You can see here programmable network on chip. It's called NOC. Then you have an AI engine tiles. So these AI engine tiles, again, you have a lot of AI fabrics in it. Like each one is like a small processor, like GPU's CUDA core, you can think. And this one tile is expanded here, and you can see the block diagram here. So this is very much suitable to run a convolutional neural network kind of, deep learning algorithm or machine learning algorithm like that. You can also use same tile to build high-end signal processing computation like FFT, FIR filter. So one block can run one FIR filter, another block can run FFT like that. So we'll be covering some basic level of coding simulation on the Versal FPGA also in this. But major focus is on the Zynq FPGA because this is new to the market, and for our company and for several companies, this a lot of things are still unexplored, and they are exploring it how to take the full benefit of Versal. Okay, now coming to the next topic. How about, sir, I want to work on EV sector. I want to work on some, other sectors. There is FPGA-based embedded systems when people build military and all. They usually have this kind of block diagram. Like in our company, if you see, you will have a digital signal processing board. You have some RF sensor board. You have some ADC card. Then you have antenna front end. Then you have antennas. A wireless system, a simplest block diagram is like this. See, because we do not want to reveal any confidential information of defense products. So mostly our references are from web-based standard, and all the links are available in the PPT. These PPT slides will be shared with you. You can read more about it. So when you are building an application on FPGA, what are all things you will be programming, and how your entire system wise design is connected with the VLSI FPGA design. This also will be covered in our course. So there are a lot of other places where FPGAs are being used today. Your AI algorithm, the generative AI algorithm or any type of AI algorithm, without FPGA, they cannot run faster, because the conventional processors, they take longer time, and certain things like high-speed camera is there, and you want to learn from camera, real-time camera and all. Even the speeds of GPUs sometimes do not match. So FPGA becomes an ideal choice. GPU becomes a second choice. But sometimes the power of both FPGA and GPU, both people take together, like how the block diagram being shown here. So these are all the different applications. So future of AI is highly dependent on GPUs and FPGAs, and future of military and embedded computing is 100% dependent on the FPGAs. And if you want to put AI algorithm also, there is anyhow Versal FPGA is there. So you can understand that in AI applications with FPGA, the advantage is you have a lot of customization. Like I said, you want to interface with 1,000 frames per second camera. You can do that with FPGA, which may not be possible with the processor. And they're good at handling multiple parallel operations, like in defense systems, like we have a dual mode operation, like a same radar can work as a search radar, track radar. It's all possible because we use FPGAs for a parallel processing in that. then FPGAs are good at doing data flow. So I have seen that the Xilinx and Altera has increased their focus on building data centers. So for Xilinx and Altera at some point of time, the major business was defense and aerospace only. But evolving the AI and data centers, the importance of data being maintained, huge data is coming in the internet. So a lot of data management also is done today with FPGA. So that's why the Xilinx and Altera, if you go to their websites, they have basically a dedicated products built for the data centers. So FPGAs are reasonably a good choice. Definitely, they're not good as ASIC when you compare with the power efficiency. But when you compare with the same FPGA, you compare with the high-end processors and GPU, these guys are definitely low power applications, in FPGA compared to the processor-based approach. So in artificial intelligence, you find FPGAs are everywhere. So when you become master in FPGA-based coding and synthesis, you would have a good career opportunities. Okay,
This I
from
will
here.
cover, sir.
Sorry?
This topic I will cover, sir.
Yeah, understood, Ravi.
Cool, sir.
Thank you.
Yeah.
So now I am ready for questions. Please shoot your questions. Anything related to technology, anything related to your career choice or skills, whatever I shared.
Guys, if anybody has any questions, you can unmute and ask, or you can also type in the chat box so that I can read it out to you. The job opportunities are only for 2025 pass outs. These questions, yes.
No, little small correction. Even 2026 passed out students, we wish to consider them for giving the pre-placement offer, but that is after this course if you complete the internship. So completion of this course successfully for 2026 pass out student means you are selected for the internship, summer internship. So during that time, we will give you pre-placement offer. Hope the point is clear.
Yes, sir. PDF link, we will be sharing the video, the recorded Zoom meeting link with all the audience who have attended today. How to start with ARM programming?
So it's fairly simple. In our course, anyhow, you will be getting the necessary background. So there are two things, like one is the standard ARM processor programming. Second one is the ARM programming through, this in VLSI, like a Zynq FPGA or any SoC and all. So it is a basic C programming. You should have a knowledge of peripherals, and we will definitely give enough introduction in this course. But yes, if you want to master, there is something called Zynq book. First you can read that, you get some bigger picture. Today nobody does assembly programming, even though the universities like ISC and IITs, some of them they still teach the ARM instruction set and all. That's only for somebody who want to compiler optimization or very less job roles who are designing ARM compiler itself or some optimizing the processor core itself. You have to write a plain C code. You should be good at how memory management in ARM is there, how peripheral management in ARM there. There is something called a standard bus called AXI bus, and the AXI bus peripherals. They are simple function calls. Like you have an SPI protocol, there is one function called SPI init will be there, then SPI read there, SPI write there. In simple words, your good coding skills in C programming with little knowledge on the, not little, I would say reasonably good knowledge on the tools like Zynq, ARM9 compiler tools and all, and any low-cost FPGA board. In fact, we would also encourage you people to buy an FPGA board and practice. Ravi can try giving 2-3 boards, on any desk-based remote sharing access. You guys can share. But if the participants are very high, it is all first come, first serve basis. We will definitely arrange, we have around some 10 plus boards, so we'll arrange them on a remote share basis or something. But you can buy them also, because today a low cost board right from 10,000, you have a board, you can buy and experiment and learn. That's it. C programming language, familiarity on AXI bus, familiarity on ARM, general peripherals and APIs. We will be definitely touching upon, and if there is a separate course for ARM programming and all, we'll share you the information.
Is tool language required like TCL or Perl?
Whatever is required, we'll train you. We are only expecting an interest and basics of digital design. Except that, nothing we are expecting. But yes, if your background is not strong enough, for example, some of you do not know the syntax of VHDL or Verilog itself, then that 2-3 weeks where we cover the module, you should give decent time to practice it. So TCL, the Perl kind of these tools which are used for the verification automation, those things will be taught in this course. Is this course for only who qualified assessment or for all? Yes, there is a written test. Saishri, did we conduct already the written test?
No, sir, we will conduct it this Thursday. We
Yes,
will share the
you should
details on.
prove your basic skill set, basic knowledge in the subject. So Ravi can give a bigger picture about in his talk what all will be checking in the first level written test. That's only to see you have minimum qualifying skill or knowledge. So somebody said registration link not working. Okay, Saishri will check it.
Yes, sir, we'll check it.
Then if we
one
learn
more
Verilog,
question.
system Verilog and digital electronics, is there any chance to get job? Yes, there are fantastic jobs are there. So if you are good at them, even I'm saying system Verilog is not required. Verilog and digital electronics, we have immediately job openings. And what we are finding difficult is people other than the AND gate, NAND gate and gate questions and all, they do not know the RTL design. It's not taught well in your standard engineering course curriculum because your course curriculum did not go beyond just coding AND gate, NAND gate, full adder, half adder, which is of really no use in the industry because we never write full adder, half adder and all. You will just use a plus symbol which automatically tool will synthesize. So that's the purpose of this course. How much of prior knowledge should we need before this course? As I said, it's the basics of digital design. Whatever is there in your standard course curriculum, ECE or EEE, the digital design, that's good enough. Ravi, are you checking some basic VHDL Verilog coding knowledge also in your written test?
No.
You are only sticking to the basics of digital design
basics.
and IQ.
Yes, sir. Yes, sir.
You have an IQ also question paper, right?
Yes, sir. There are two sections in the question paper.
Yeah,
one
so
is
we'll
IQ
also,
and one is subject con.
Yeah, we
That
also
questions I
check
will
your
answer
basic
it.
IQ. IQ is a typical English and also your intelligence check kind of thing. Simple question paper only. Okay, so I think I have answered all. So I will give it to the organizers.